Hello everyone, welcome you all for mathematics class. In previous classes we discussed about the graphical representation of the inverse trigonometric functions. In this class we will discuss about the principal value of inverse trigonometric functions. In order to find the principal value, we will know the domain and ranges of inverse trigonometric functions. So here inverse trigonometric functions: sine inverse, cos inverse, tan inverse, cosec inverse, sec inverse and cot inverse, and domain value and range values. Domain value of the sine inverse function is a closed interval -1 to 1, and a range are principal value branch. Principal value branch means a function which selects one branch of a multi-valued functions. A range or principal value branch of the sine inverse function is a closed interval -π/2 to π/2, and a domain of the cos inverse x is a closed interval -1 to 1, and a range of the cos inverse function is a closed interval 0 to π, and domain of the tan inverse function is a all real number, and a range of the tan inverse function is a open interval -π/2 to π/2. Here exclude the -π/2 and π/2 points, and domain of the cosec inverse function is a all real number except open interval -1 to 1, and the range of the cosec inverse function is a closed interval -π/2 to π/2 except 0 value, and domain of the sec inverse function is a all real number except open interval -1 to 1, and the range of the sec inverse function is a closed interval 0 to π except π/2 value, and the domain of the cot inverse function is all real number, and range of the cot inverse function is a open interval 0 to π. So observe the range value. So sine inverse closed interval -π/2 to π/2, and cosec inverse, cosec means it is a reciprocal of the sine function. Observe this range value, closed interval -π/2 to π/2 except 0. So compare these two, and same way cos inverse and sec inverse. Here range value is a closed interval 0 to π, sec inverse is a closed interval 0 to π except π/2 value, and a tan inverse is a open interval -π/2 to π/2, and the range of the cot inverse function is a open interval 0 to π. And very important notes. So first note, sine inverse x should not be confused with the sin x power -1. In fact, sin x power -1 means it is a 1 by sin x, but sin inverse x is not equal to 1 by sin x, and similarly for other trigonometric functions. And a second note, the value of an inverse trigonometric functions which lies in the range of principal branch is called the principal value of that inverse trigonometric functions. So it is a very important note. The value of an inverse trigonometric functions which lies in the range value of the principal branch. It means a range of principal branch of the all inverse trigonometric functions is very important. Angles of trigonometric functions. Angles: 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 180 degree, and angles: sine angles, cos angles and tan angles. Sine 0 is 0, sine 30 degree is a 1/2, sine 45 degree is a 1/√2, sine 60 is a √3/2, sine 90 degree value is a 1, sine 180 degree value is a 0. So 0 degree, 30 degree, 45 degree value is a radian value is a 30 degree means 5/6, 45 degree means π/4, 60 degree means π/3, 90 degree means π/2, and 180 degree means π. These are the radian values. The same way cos and tan functions. So trigonometric table is very important. And so before going to the examples based on the principal value, so these are the important formulae. Sine of sine inverse x is a x. For suitable x value, sine of sine inverse x is equal to x. So x belongs to the range of sine function. Same way, sine inverse of sine x is also x, and x belongs to the range value of sine inverse function. In the same way, other trigonometric functions. And the third formula, sine inverse of minus x is a minus sine inverse x, and a cosec inverse of minus x is a minus cosec inverse x. Tan inverse of minus x is a minus tan inverse x. Sine, cosec and tan. Cos inverse of minus x is a pi minus cos inverse x, and sec inverse of minus x is a pi minus sec inverse x. Cot inverse of minus x is a pi minus cot inverse x. These are the very important formulae. And other formulae, cos of pi minus x is a minus cos x, or minus cos x means minus cos x means cos of pi minus x, or minus cos x is a cos of pi plus x. So two formulae, cos of pi minus x is also minus cos x, cos of pi plus x is also minus cos x, and the sec of pi minus x is a minus sec x, cot of pi minus x is a minus cot x. Now consider the example. Find the principal value of sine inverse 1 by root 2. Solution of this function. So let sine inverse of 1 by root 2 equal to y. So take sine on both sides. Sine of sine inverse of 1 by root 2 equal to sine y. And we know that sine of sine inverse x is a x. 1 by root 2 equal to sine y. And what angle has a sine of 1 by root 2? Sine 45 degree value is 1 by root 2. So that is sine in radian value pi by 4. Sine pi by 4 equal to sine y. Considered as a equation 1. And we know that the range of sine inverse function, is a closed interval minus pi by 2 to pi by 2. And sine pi by 4 value is a 1 by root 2. So therefore the principal value of sine inverse of 1 by root 2 is pi by 4. So first consider the given function. Sine inverse of 1 by root 2 equal to 1. So take sine function on both sides. So that is sine of sine inverse of 1 by root 2 equal to sine y. And we know that sine of sine inverse x is a x. So that is 1 by root 2 equal to sine y. And what angle has a sine 1 by root 2? So that is 45 degrees. Sine pi by 4 is 1 by root 2. Sine pi by 4 equal to sine y. We know that the range of sine inverse is a closed interval minus pi by 2 to pi by 2. And sine pi by 4 value is a 1 by root 2. Therefore, the principal value of the given function, that is sine inverse of 1 by root 2, is a pi by 4. Or in another way, so consider the given function. So let sine inverse of 1 by root 2 equal to y. So then sine y is equal to 1 by root 2. So because consider sine inverse in RHS, that is sine y is equal to 1 by root 2. And sine y as it is. So what angle has a sine of 1 by root 2? That is sine pi by 4. So y is equal to, consider sine in RHS, that is sine inverse of sine pi by 4. So y is equal to sine inverse of sine x is the x, that is pi by 4. So y means sine inverse of 1 by root 2. Sine inverse of 1 by root 2 equal to pi by 4. So check pi by 4 belongs to the range of sine inverse function. That is, range of the sine inverse function is a closed interval minus pi by 2 to pi by 2. So here pi by 4 belongs to the range of the sine inverse function. So therefore the principal value of sine inverse 1 by root 2 is pi by 4. Principal value of sine inverse of 1 by root 2 is a pi by 4. So I hope you understood. So take the next example. Find the principal value of cot inverse minus 1 by root 3. Solution of this function. So first consider the given function. So let cot inverse of minus 1 by root 3 equal to y. So then, take cot on both sides. Cot of cot inverse of minus 1 by root 3 is equal to cot y. So cot of cot inverse x is a x. Here x is a minus of 1 by root 3. Minus of 1 by root 3 equal to cot y. And negative sign as it is. So what angle has a cot of 1 by root 3? Cot pi by 3. Cot pi by 3 equal to cot y. So you must know the all angle values. So minus cot pi by 3 equal to cot y. Sin cot of pi minus x is a minus cot x. So here minus cot x. So you can write cot of pi minus pi by 3. So because cot of pi minus x is a minus cot x. Cot of pi minus pi by 3 value is a minus cot pi by 3. So in RHS as it is cot y. So cot. So take the LCM. So 3 is the LCM. 3 pi minus pi. So that is 2 pi by 3. Cot of 2 pi by 3 equal to cot y. And we know that the range of cot inverse. The range of cot inverse is a open interval 0 to pi. And cot of 2 pi by 3 value is a minus 1 by root 3. Cot 2 pi by 3 value is a minus 1 by root 3. So therefore principal value of the given function cot inverse of minus 1 by root 3 is 2 pi by 3. is the principal value of the given function, that is cot inverse of minus 1 by root 3. So observe this example. Cot inverse of minus 1 by root 3 equal to, so consider cot inverse of the minus 1 by root 3 equal to y. So take the cot on both sides. Cot of cot inverse of minus 1 by root 3 equal to cot y. Cot of cot inverse x is a x. Here x is a minus 1 by root 3. In RHS, cot y as it is. And what angle has a cot of 1 by root 3? So cot pi by 3 minus negative sign as it is, cot pi by 3 equal to cot y. And we know that minus cot x is a cot pi minus x. Cot pi minus, here x value is a pi by 3 equal to cot y as it is. Cot pi minus pi by 3 means cot 2 pi by 3 equal to cot y. And we know that the range of cot inverse is a open interval 0 to pi. And cot of 2 pi by 3 value is a minus 1 by root 3. So therefore principal value of cot inverse of minus 1 by root 3 is a 2 pi by 3. So here 2 pi by 3 belongs to the open interval 0 to pi. And next, exercise 2.1. In 2.1, first example, find the principal value of first example, sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2. Solution. So first consider the given function. Let sine inverse of minus 1 by 2 equal to y. Then sine inverse of 1 by 2 equal to sine y. So take sine on both sides. And sine of sine inverse x is a x. Minus 1 by 2 equal to sine y. Negative sign as it is. What angle has a sine of 1 by 2? That is sine pi by 6. Sine 30 degree value is 1 by 2. Negative sign as it is. Sine pi by 6 equal to sine y. And minus sine x is a sine of minus x. So here sine of minus pi by 6 equal to sine y. Or y is equal to, so take sine in LHS. So that is sine inverse of sine of minus pi by 6. Y is equal to sine inverse of sine x is a x. That is minus pi by 6. Y means sine inverse of minus 1 by 2 equal to minus pi by 6. And we know that the range of sine inverse is a closed interval minus pi by 2 to pi by 2. So here minus pi by 6 value is belongs to the closed interval minus pi by 2 to pi by 2. So therefore the principal value of sine inverse minus 1 by 2 is a minus pi by 6. In next class we'll discuss about the more examples based on the principal value. Thank you.